as you know, I will organize all this information so I can graph the function. So f prime, f of x, and the second derivative. Stop me anytime if you have questions. So I'm assuming negative infinity to infinity. I'll see in a moment. Obviously, at x equals 0, everything is undefined. So x equals 0 is a VA. So that is taken care of. The first derivative is positive for x less than negative 2. So positive for x less than negative 2. Is negative for greater than negative 2. The second derivative is less than 0 for x less than 0. And it's positive for x greater than 0. So the function here has a local max, a vertical asymptote, and here it holds water. Okay. So I don't have to draw this again. So x equals 0 is a VA. I know the function cannot cross there. And at negative 2, it has a local maximum. So increasing, decreasing. So I'm going to say this is the local maximum for me. And since it's a vertical asymptote, I can do this, but I can't because of the opening down, right? So I was thinking that maybe I could do this, but I can't because it's very clear it has to open down on this side. And on this side opens up, and I can do whatever I want, and I can just present this. Always decreasing and always opening up. Other questions or anything about this? Any questions about that? Oops, I know. Of course, I pushed my computer so that I have more room, and yeah. Okay, anything else? Other questions from anything?
Yeah. Can you do same section, number 46?
Good. So let's take a look. I'm going to share 46, 44, 5, 6. Okay, so we're asked everything. Okay, so 46, we have f of x equals 36x plus 3x squared minus 2x cubed. And they want everything. So the first thing I do, I will definitely factor out a negative x. And I get 2x squared minus 3x and minus 36. I don't know if that means a lot or not. I don't know if this is factorable. That's 72. Maybe, maybe not. I can determine the solutions right away because I have to find the x-intercepts. They should be 3, unless these are imaginary, which I doubt. So I'm going to go to the graphing calculator and to the apps, and I want number 9. And yes, it's a polynomial. Yes, it's polynomial degree 3. Although I don't need to, because it's obviously I already have a one solution. And the next, so the first coefficient is 2. I didn't mean that. So I have to start from scratch. Okay, so I want that. Okay, well, the enter doesn't work, so I guess I have to click on graph. So 2, does it allow me to? Okay, so then that is negative 3. And then enter. Okay, good. And the last one is negative 36. So negative 36. Okay, and I guess graph will solve it. Okay, fine. So we get x equals 0. X equals negative 3.6 and x equals 5.1. So we have the x-intercept already. And since I see the leading coefficient is negative, that's the leading coefficient, right? -2. So the limit right away as x approaches negative infinity, and the limit of f of x as x approaches infinity should be determined right away. Because when x approaches negative infinity, this term dictates. The other ones are too small to mention. Since this is negative and you plug in a negative, so it's going to be positive infinity, and this one will be negative infinity. So I already discovered everything about the function from the function itself. So I'm going to start my table. With f prime, f of x, and the second derivative. And I'll put negative infinity to infinity. And I have 0 in the middle. I have negative 3.6. And I have 5.1, 0, and 0, and 0 at negative infinity, infinity, at positive infinity, negative infinity. Done. The function is completely done. Now I have to find the derivative. So f prime of x will be negative 6x squared plus 6x plus 36. So bring down 3, so negative 6x squared plus 6x plus 36. Yes, of course, right away I will get it ready. X squared plus x, no, it's minus, and minus 6. Get it ready and factor it so you make your life much easier. So then this is negative 6 with x minus 3 and x plus 2. So I know that f prime of x is 0 at 3 and negative 2. So negative 2 is here and 3 is here. Stop me if you have any questions so far, please. Okay, the leading coefficient tells me that the function has a maximum. I'm not graphing the derivative, but the function looks like this, which means it's positive between solutions and negative outside. Now the moment of truth. At this point, I will make sure that these two rows are in sync. Otherwise, I have to go back and check and find my error. So from negative infinity to 0, from positive infinity to 0, yes, that's correct. Oh, I forgot to determine these two. I have to plug in negative 2 in the function and 3 in the function before I continue. So I'm going to do it just here locally. So I'm just going to, because you know what I'm doing. So negative 2x to the third, and then plus 3x squared, and plus 36x. So I just plug in negative 2 and 3. No, negative 2 and 3. Okay, so I got here negative 44, and for 3 I got 81. Okay, so from 0 to negative 44, yes, that's true. Yes. From negative 44 to 0, yes, indeed. From 0 to 81, yes, indeed, that's true. From 81 to 0, yes, indeed, yes, indeed. So I noticed that this is definitely a local min, and this 381 is a local max. Negative 2 comma negative 44 is a local min, 3 comma 81 is a local max. And now the second derivative, and no, I will not differentiate this. I will definitely differentiate the expanded one. Any questions so far? Stop me, please. Okay, so now I'm on page 3. So the second derivative is negative 12x plus 6. And when I set this equal to 0, I get 1/2. 6 over 12. Of course. Are you surprised that the 1/2 would mess my table up? If I were in a test situation or even homework, I would redo my table because I have to squeeze in here 1/2 and 0, and I have to squeeze in here a number. right? So I have to plug in the function. I can determine, so I also recommend that. So this is 18.5. I also recommend to find those points before you start the table. Maybe that is the best. And then I have a negative leading coefficient, which means this function follows this sequence of sign, positive and negative. Or you can plug in numbers. Good. So this is it. So 1/2 this, 1/2 18.5. This is an inflection point. Done. So now let's graph. I only need my table. The function is not symmetric. We can plug in, so I'm gonna, but I have to write here somewhere. F of negative x does not equal f of x, and it does not equal negative f of x, not symmetric. Okay, that's all I need, my table. Okay, so I will start with the points I have. And negative 3.6, comma 0, negative 2. That's not a nice one. So negative 2, negative 44, I'm going to say negative 10, negative 20, negative 30, negative 40, negative 44. So this is negative 10, negative 20, negative 30, negative 40. And the same up. Okay. So that will be the local minimum. Now I have 0, 0. And now I have 0.5, 18.5. So this is 10, 20, so 0.5, 18.5. And then I have 381, 10, 20, 30, 40, 50, 60, 70, 80. I'm going to say right here. And 0, 5.1. Okay, ready. Let's do this. Which color? Maybe green. Okay, so from positive infinity, crossing the x-axis. From positive infinity down, opening up, crossing the x-axis, decreasing. Coming to the local minimum. That is at negative 2, negative 44. And then going up to 0, opening up, continuing to 18.5 where it has an inflection point. So it changes concavity. It gets to the maximum. 3,81 is the local max. Comes back to cross the x-axis. Always decreasing here, going to negative infinity. So this is the graph of negative 2x cubed plus 3x squared plus 36x. Always have to write the graph, the function next to the graph, so we know what we graphed. I don't think that this is really possible without organizing the information in a table. It will be very difficult for you to look at 3 pages of work. If you don't organize it, it will be very difficult. Yes, if I were you, when you redo this problem, if I were taking this class, I would definitely do this and work on the problem step by step one more time and put them correctly. They are correctly in the correct order, but I need more room between 0 and 3, so this fits and it's clearly in there. Okay, very good question. Anything else? Other questions from anything?
Yeah, I have a question.
I'm ready.
Can
Yes.
Number
Yes.
42 from the assignment.
You said 42?
22.
Oh, 22.
I have to check.
You mean this one?
But yes, that one.
Okay, what are we asked? Concavity. Okay, so f of x e to the x over e to the x plus 2. Good.